We're here with Ben Harris. Ben is talking about that microbiome today. Now, I'm sorry, but I'm going to have to admit my lack of knowledge in this area. I don't know what a microbiome is, so could you tell me what a microbiome is?
Microbiome, few of us know what a microbiome is.
Good, thank goodness.
But we do know we're each of us made up out of something like 10 trillion tissue cells.
Okay.
That's you and I. They're relatively large. The bacteria are small, so there's 10 trillion of us and 90 trillion of them after we've had a shower. 10 trillion of us, 90 trillion of them. Now clearly when we're in good health, we're not even aware of them. In fact, we need them for our good health. It's absolutely integral that 90 trillion is working in synergy with us to make sure we have good health outcomes.
So I guess my next question is going to be what happens when it doesn't work in synergy?
We're just at the very, very beginning. Since about after the human microbiome, I should say the Human Genome Project, over 10 years or so and several $1 billion, it was found we're made up out of 23,000 genes and all the rest of it. Since then, using those same techniques, that's been turned on to our microbial mass, our microbiome, our 90 trillion. And that's only happened since about 2007. And there's hundreds to thousands of papers since then about that and about what they do to us, these microbes. It's like an ancient forest, and we have different ancient forests of different species of microbes in different parts of our body. So on our skin, our mouth, our GI tract, it's a complex ancient forest. That is populated by, when we're born, or before we're born, we're sterile, or perhaps new evidence would say near sterile. Then the placenta bursts, and we are sterile soil, if you like, we start getting populated with these microbes. And we get a mouthful of essentially mother's perineal cum fecal flora, and that goes into our gut and becomes the heart of our new immune system. And that's very good, that's where it happens. Now a third of us have cesarean sections.
I was going to ask about that.
So, that's right. And so the concerns was, is there any difference between cesarean birth and vaginal birth? And when the 3-month-old, 6-month-old, 9-month-old babe is looked at, no difference at all, none found so far. But when we look at the 8-year-old and the teenager, higher eczema, dermatitis, obesity, and a whole lot of other things which we're just starting to realise now. So that's right from the very beginning. Then you move on to such things as, are they breastfed or bottle fed? Each of these processes has different input of bugs which populates our ancient forest differently. As does preterm antibiotics before birth to get rid of group B strep. There's an upside to it, but there's a downside. It wipes out the microbiome of the mother, so the babe gets less and comes on. Then we know that something like 3 to 4 courses of antibiotics as a babe, I shouldn't say as a babe, as under 5-year-olds, 3 to 4 courses of antibiotics will double their chances of irritable bowel disease.
Is that right?
So the ratios of bugs in our gut flora has many health effects on us. Obesity is one. Genetics is a small part of obesity. Our microbiome and our environment, including diet, is major. Then there is moods, and we can prove moods are changed. Depression is changed by our microbiome. You know, eczema, dermatitis is, and there's a whole lot of other things we're just starting to realise ties up. Things like autism are now being looked at, plus the autoimmune illnesses, Crohn's, irritable bowel disease, multiple sclerosis. There's a strong link through to the microbiome, the type and the ratio of bugs in our gut flora.
That's interesting because I went to a birth recently, a cesarean section, and although it was completed, the midwife then took a sample of the woman and put it in the baby's sort of surrounded around the face.
To try and seed them with what they would have had vagina, and that's the current, seems like the right thing to do. There's one paper that says, but what happens if you give them group B strep?
That's a good point.
So maybe 12 per 100 women will carry group B strep as part of their normal flora. So there's a balance of risks. But personally, from what the tiny bit anybody knows about the microbiome, we're going to learn a huge amount over the next 20 to 25 years. I'd sooner be seeded with mother's flora by far and take that risk on.
Okay.
It has medium to long-term effects on our good health.
Okay. Let's put this in a GP's perspective. Why should they know about the microbiome?
Because the GP's primarily there for health, and they want to do the best they can for health. One of the troubles with antibiotics, they are brilliant, there's no question. The downside of antibiotic, it gives a quick fix solution, but we're only just starting to be aware of the long-term effects. When we take the antibiotic, it treats our 90 trillion, changes the ratios, changes our microbiome, which may never recover. So it's like putting Agent Orange over an ancient forest to get rid of the clover. The clover may have been bad, but we do irreparable damage. And recently I used the example, Zika virus, how dreadful. Should we use DDT for it? Or do we wipe out all the mozzies, wipe out Zika? But we've already learned that DDT does things, it never breaks down, it hardly breaks down, it concentrates in the fat, it has genetic issues, and we would be horrified to use DDT. That's an uh-oh moment when we realised how bad DDT was. It's got lots of good things, but bad. We're about at that moment with antibiotics at the moment.
I see.
We know they do some brilliant things, but there's an uh-oh moment. We may be causing significant downstream ill health, chronic ill health problems for that patient.
I see. Okay. So say we did put down Agent Orange and we did wipe out the forest.
Yes.
How do we populate the microbiome in the right way with the right?
It's a very good question. Actually, we've lost half the species already. Since 1943, when antibiotics became available, we now know we only have half the gut flora that we had prior to 1943. We know that by looking at fecal samples of Iceman and others that have been frozen in glaciers and such like. We have half the species. We know that isolated communities, and there's almost none of them in the world, non-industrialized communities, they have a widespread microbiome. So it's a bit of a problem. We will have to learn the different yogurts, prebiotics, probiotics, and we have to get back probably to that Paleolithic diet of eating berries, roots, and feeding our gut flora, which includes things like artichokes and such like, the fibre and such like. So the simple sugars get absorbed higher up, but the complex oligosaccharides and the fibres, they go down to feed our gut flora. So we not only need to get more species down there, but we need to feed those that are there. And fats and fast food and all of these things starve it. And we know, for instance, with taking saccharin or sugar substitutes, it seems like a good idea to stop the calories coming in, which stops the obesity. But actually, that starves the bacteria that can utilize the sugar, and we increase their glucose intolerance by using the saccharin, because they're starving them, which tends to make you obese, which is ironical. So there are a number of cause and effects.
So using my Equal tablet in my cup of tea is not really helping me at all.
I'm saying, like always, there's an upside and a downside. Very diplomatically said, I might add. But everything we put in will have an effect on our gut flora. And we're just at the tiny beginning, and learning the difference between cause and effect and association is what we have a lot to learn about. For instance, one of the bacteria, Lactobacillus reuteri, produces lots of oxytocin, and that makes us sociable. So in mice, and it's recently been published in Cell, that mice that were fed high-fat diet had very low amount of Lactobacillus reuteri, and they showed their micelings, when they were mated, we'll call them micelings, they showed autistic behaviors with being antisocial. Whereas those mice that were fed normal mouse diet, had plenty of Lactobacillus reuteri, they were very sociable. When we contaminated the water with Lactobacillus reuteri of the micelings from the obese mice, they immediately became sociable.
Okay.
And so we try and think, does that apply to humans? Does it? And we know it does. And we know oxytocin makes us sociable.
I'm going to change my diet.
So I think the key message is we need to have as much microbial input as we reasonably can with the berries and fruits, and we need to feed our gut flora and the colon with fibres and complex polysaccharides and complex starches. Feed those, develop those, and not wipe them out with antibiotics. And when we change all of those by one course of antibiotics from an infected sore, we help change that in unbelievable ways we're just starting to realize. So be very sure we realize the risk before treating that infected thumb. Would it get better, albeit over a few days longer, if they were not treated?
That's very true. Okay. Thank you, Ben, for coming along today and having a chat with us about microbiome. Very interesting and very big topic that you've got. It's something I would definitely like to look into a bit more, particularly around if there's ways that we can improve ourselves and changing that microflora.
Thank you, Carrie. Very welcome.
Okay.